When the dry season hits the African continent, entire river systems evaporate into cracked earth. The water that remains stagnates, oxygen levels plummet, and the shallow pools become highly toxic. Most aquatic life suffocates within days. But for one particular species, a bubbling, overheating mud puddle is not a death sentence. It's an everyday reality. Welcome back to Wild Inside, Song Sut Lok. Today, we're tracking the African Sharptooth catfish. Dominating these massive, sprawling waterways requires competing with heavily armed predators, all while surviving an ecosystem that actively tries to kill its inhabitants every single year. Standard aquatic adaptations fail here. Enduring months of dehydration and toxicity demands highly specialized, almost alien biology. That biology operates as a perfectly engineered offensive and defensive toolkit. Analytical. Looking at the top left of this biological breakdown, starting right at the mouth, you'll see rows of sharp, inward-facing teeth. They aren't meant for chewing. They act like a lock to trap struggling prey. Panning down slightly to the barbels, we see its primary hunting mechanism. These highly sensitive whiskers detect microscopic vibrations, allowing the catfish to strike accurately in pitch-black water or thick, opaque mud. This diet section highlights a row of 5 distinct prey icons: fish, shrimp, crabs, frogs, and snails. It is entirely indiscriminate, extracting calories from whatever protein is available. Switching over to its defensive armor on the upper right, it features a rigid dorsal spine. If a larger predator attempts to swallow it, this spine locks into place to puncture the attacker. Below that, the skin is covered in a thick, sticky mucus layer. When the water turns stagnant and toxic, this slime acts as a biological shield, blocking infections and parasites. This heavy biological armor is paired with intense territorial aggression. It attacks intruders on sight, heavily guarding its feeding and breeding grounds. By combining highly sensitive hunting optics with toxic water defenses, it nullifies the standard threats of its environment. But repelling predators and filtering bacteria doesn't solve the final problem of the dry season, the total disappearance of dissolved oxygen. When a river turns to mud, gills become useless. To bypass this, the catfish developed a severe biological anomaly. This green anatomical diagram on the right shows a modified gill structure. This organ allows the fish to breach the surface and breathe atmospheric air directly. When surface water vanishes completely, it uses this air-breathing capacity to physically wriggle backwards, burying itself deep into wet mud to wait out the drought. Because it isn't limited by the oxygen levels in the water, it can support massive physical growth. As the size chart here illustrates, a fully grown adult can stretch up to 150 centimeters and pack on 60 kilograms of mass. The life cycle diagram in the center confirms the long-term effectiveness of these traits, noting a wild lifespan of 10 to 15 years. While competing species suffocate and stunt their growth, the sharptooth catfish simply breathes the air and continues to expand. These exact survival mechanisms eventually caught the attention of human agriculture. An animal that grows rapidly, eats anything, and thrives in densely packed, poorly oxygenated water is an ideal agricultural commodity. Because of this, the species was exported out of Africa. Today, massive, grid-like floating fish farms across Asia, Europe, the Americas, and Australia cultivate them in enormous volumes. Its extreme resilience directly translates into high-yield, low-maintenance protein, feeding millions of people in daily markets around the world. This explosion in global farming means the species itself is highly secure. As the green badge in the bottom left corner of our chart shows, its conservation status is firmly least concern. However, the native African river systems where it originally evolved face a different reality. Industrial pollution and habitat destruction severely pressure these waterways, threatening the local communities that rely on them. Supporting sustainable fishing practices and protecting these natural rivers is essential to maintaining the ecosystems that built these resilient species. Thank you for joining us on Wild Inside Song Sets. If you enjoyed this breakdown, leave a like and subscribe for more. The sharptooth catfish spent millions of years evolving armor and lungs to conquer an unforgiving wilderness, and in doing so, engineered itself into the perfect product for human industry.